Hey everyone, welcome to iTower. Today, we're going to explore multi-threading in JavaScript and how it can significantly improve the performance of your applications. Unlike some other programming languages, JavaScript is traditionally single-threaded. This means it runs all operations on one thread, and if a task is resource-heavy, it can block the UI and make the application unresponsive. But JavaScript does have ways to manage concurrency and execute tasks asynchronously using web workers. Before we jump into the code, don't forget to like and subscribe to the channel. Your support really helps me bring more useful content to you. Now, let's dive into multi-threading in JavaScript. As we mentioned, JavaScript typically runs on a single thread, which can be a bottleneck when performing computationally expensive tasks, like processing large datasets or complex calculations. In a single-threaded environment, when a heavy task is running, the UI thread gets blocked, and the user can't interact with the page. The solution to this is multi-threading. JavaScript doesn't have traditional multi-threading like some languages such as Java, but it does allow us to achieve similar results through web workers. A web worker runs in a separate thread, completely isolated from the main thread, which means it can perform tasks concurrently without blocking the UI. Let's look at an example of how to use web workers to offload heavy computations to a background thread. First, let's start with the main JavaScript file that will create the worker. In this example, we instantiate a new worker by calling newWorker, where the JS file is the one containing the code that will run in the background thread. We also listen for messages sent from the worker using onMessage. Whenever a message is received, the function logs it to the console. Afterward, we send a message using postMessage, instructing the worker to start the calculation or task. Now, let's take a look at the worker script, which contains the code that runs in the background thread. Inside this file, we listen for incoming messages from the main thread using onMessage. When a message is received, the background process begins, in this case simulating a long-running task by performing a computation. Once the task is completed, we use postMessage to send the result back to the main thread, allowing it to continue executing without being blocked. By using a web worker, the heavy computation is offloaded to a separate thread, and the UI thread remains free to handle other tasks, such as user interactions or UI updates. This is especially useful in web applications where you might have to handle large datasets, perform complex calculations, or run background tasks like data fetching or analytics. Let's take a closer look at how this helps with performance. Without using a web worker, if we were to execute this long-running calculation on the main thread, it would block the UI, and users wouldn't be able to interact with the application until the computation is finished. This could result in a poor user experience. With a worker, the calculation happens in a background thread, and the UI remains responsive throughout. But keep in mind that there are some caveats when using web workers. Web workers don't have access to the DOM, so they cannot directly manipulate the user interface. They also communicate with the main thread via messages, so you need to serialize data when sending it between threads. This can add some overhead for large or complex data, so it's important to balance the complexity of using workers with the performance benefits. Now let's look at a more complex example where we need to process a large dataset. To make the data processing faster, we can divide the dataset into smaller chunks and assign each chunk to a separate worker. Here's the updated code for the main JavaScript file, where we manage multiple workers. In this example, we use a for loop to create multiple threads. For each iteration, we instantiate a new worker, passing the worker.js file which contains the background code to be executed. Each of these workers processes a portion of the dataset concurrently, allowing them to handle their tasks in parallel and reduce the total time needed. In the main file, we first divide the dataset into smaller chunks based on the number of workers. To determine the size of each chunk, we calculate it by dividing the total length of the dataset by the number of workers, rounding up if necessary. For each chunk, we create a new worker and send the chunk to it using worker postMessage. This ensures that the workers can run their tasks simultaneously without blocking the main thread. As each worker processes its chunk and sends the result back, we collect the process data in an array called process data. Once all the workers have finished their tasks and the length of the process data matches the length of the original dataset, we log the final result to the console. By leveraging multiple workers, we efficiently parallelize the task of processing the dataset, which is much faster than processing it on the main thread, where the UI could be blocked. This approach ensures that the computation doesn't affect the user experience. Now, let's dive into the worker.js file. This script contains the code that is executed in the background. Inside this file, we listen for incoming messages from the main thread using onMessage. When a chunk of data is received, the thread processes it. In this case, we simulate the processing by transforming each item in the chunk to uppercase. Once the task is completed, we use postMessage to send the result back to the main thread. This approach significantly improves performance, especially for large datasets, because it allows us to process data in parallel. Rather than processing the entire dataset sequentially on the main thread, we divide the work across multiple workers, reducing the overall processing time. To summarize, JavaScript doesn't have built-in multithreading, but we can use web workers to offload tasks to separate threads and achieve parallelism. Whether you're using a single worker for background tasks or multiple workers to process chunks of data in parallel, web workers can help you keep your applications responsive and improve performance. Just keep in mind the limitations, such as no DOM access and communication overhead, and make sure that workers are the right solution for your use case. I hope you found this video helpful. If you did, don't forget to like, comment, and subscribe for more deep dives into JavaScript and web development. Thanks for watching, and I'll see you in the next video.